right, so on your red paper, I want you to write chapter 9, sequences and series. Josh, would you pass the hole punch around, please? You need to hole punch the extra credit and these red sheets of paper. The red sheet of paper goes in front of all of your notes. And this is the next chapter. If you missed your exam and have not emailed me, you got a big 0. All right, so 9.1, we're going to be talking about patterns. And as I was like creating your lesson plan, I kept thinking of something. Did you guys watch SpongeBob growing up? Please tell me you watched SpongeBob and I didn't miss a generation. Yeah. So what do you remember what Plankton was always looking for from Mr. Crab? Yeah, the formula, the secret formula. We're going to be talking about formulas. So you're going to put definition. And we're going to talk about a formula. So if you think about formulas, there's always like a secret ingredient. There's always something that you don't know. So there is going to be a variable. Which is something that we don't know. So it will be a variable equation. Now let's talk about a sequence. A sequence is a list of numbers. So a list of numbers and those numbers are called terms. So an example of a sequence is going to be like this, where the entire thing is the sequence and each individual part is a term. Now, A sub n is going to be the name of your sequence. So A sub n is a name. A sub 1 is going to be called the initial condition. We've run into initial conditions before, but the initial condition is like your starting term. It's your first term, hence A sub 1. N is going to be the number or place of your term. So the number or place of your term. It's like its place in line. And A sub n minus 1 is going to be called a consecutive term to A sub n. This is all going to sound very foreign until we start doing some of the problems. So let's talk about an example. Let's look at this way. You're going to be given some terms. Let's go back to that 0, 3, 6, 9, 12 example. What is this sequence called? What's the name of this sequence? Now this is going to be pronounced A sub n. Now, if you want to write something at the top of your page, this will probably be helpful. Do we know the difference between subscript and superscript? Any ideas? Subscript you can think of like a little submarine. It goes below. And it's read A sub n. Subscripts are used to name something. So this is a name. Now, superscript, you can think about Superman. Superman with a really messed up neck. Superscripts are above. So you can think of like n squared. And this has to do with a value. So this is like a number. So reviewing that, what is the name of this sequence?
A sub n.
Yeah, A sub n. I'll leave that superscript up there for a second. So A sub n, that whole thing is going to be A sub n. Now, what you're going to be doing whenever you're given some things like this 0, 3, 6, 9, 12, is you're going to be creating a table. And you're going to have an n on one side and an A sub n on the other side. So for A sub n, you're going to put 0, 3, 6, 9, 12 in the exact same order that it came. What was the definition of n? What did we say n was? So what did I say on this slide? Yeah, it's the place. It's wherever it's kind of like its place in line, right? So 0, that is our first term. 3 is our second term. 6 is our third term. 9 is our fourth. And 12 is our fifth. So we would write 0 as being the same thing as a sub 1. Because if you notice, I'm saying my n, whenever it's 1, it's going to be 0. So if my n is 1, I'm going to substitute it in that spot to have a sub 1. Now, what was a sub 1? What was the definition of a sub 1? Yeah, it's your initial condition. So if this guy is a sub 1, what do you think this one is? A sub 2. And the next one? Yeah. Emma, what do you think the next one is? How do we read it the correct way? A sub 4. And then Kaden, what about the last one? A sub 5. So those are all of the names of the terms. So if I was talking about consecutive terms, being consecutive terms, give me one of our A's. Which one do you want to use? A sub 5, A sub 4? Okay, let's use A sub 3. Notice that I substituted that n for 3. Okay, so if I'm looking at A, I again am going to substitute that for 3. So A sub 3 and what? A sub 2? These guys are consecutive terms. Consecutive terms means it's just one right after another. So A sub 1 and A sub 2 are consecutive terms. A sub 2, A sub 3 are consecutive terms. A sub 3, A sub 4 are consecutive terms. And A sub 4, A sub 5 are consecutive terms. So I baby step this because we are going to have equations where we are going to have to substitute A sub n and A sub n minus 1. And we're going to need to know which term we're talking about. So for the start of class, we are going to be talking about recursive formulas. I'll let you know whenever we start on our other formulas, which are going to be explicit formulas. But for now, we're starting out with recursive formulas. A recursive formula has two different parts. So first, it has an initial condition. And what was that? Yeah, A sub 1. And then second, it has a formula of consecutive terms. What was a consecutive term?
A sub n.
Very good. So an example of this is if we have find the first 5 terms in the sequence. Find the first 5 terms in the sequence. And it is going to say something like a sub n is equal to 2a sub n minus 1. It'll give the condition where a sub 1 is equal to 3. So what you're going to do is you're going to have n and you're going to have a sub n. And I have an initial condition, right? I have an a sub 1. So I'm going to put that here because that's a sub 1. So if I'm looking for 2, I don't know what 2 is. So I'm going to go over here. I'm going to say I need to find a sub 2. So that equals 2 times a sub 2 minus 1, which is going to be a sub 2 or 2 times a sub 1. What did we say a sub 1 was? Yeah, the initial condition, but in this example, yeah, it's going to be 3. So we're going to have 2 times 3. So here it's going to be 6. If I'm trying to find a sub 3, I have 2 times a sub what? It'll be a sub 3 minus 1, right? Because it's n minus 1. So a sub 3 is going to be 2 times a sub 2. What was a sub 2? Elijah? What was a sub 2? 6. So it's going to be 12. I want you all to find on your own a sub 4 and a sub 5. All right, Ethan, what's the 4th term in the sequence? So the 4th term, we are going to have a sub 4 being equal to 2 times a sub 4 minus 1. So a sub 4 is going to be 2 times a sub 3. What is a sub 3? And 2 times 12 is 24. Elijah, what about a sub 5? So a sub 5 is equal to 2 times a sub 4, which is going to be 2 times 24, or 48. we're also going to be asked to create our own recursive formula. So we're going to be given a list of numbers, and it's going to ask us to represent this in some sort of equation. So, for example, write a recursive formula. Now, sometimes this will say definition. Sometimes it'll say definition. Those two things are the same. For each sequence, and let's say that we are given the numbers 80, 77, 74, 71, and 68. Your first step is going to be to create a table. So why don't you try and create a table on your own sheet of paper? What is my initial condition, Josh?
Um, 80.
Yeah. So create your table. Then you just go down the line. On the left-hand side here, I'm just going to say, okay, this is my first term, this is my second term, this is my third term, this is my fourth term, and this is my fifth term. So another name for 77, just like another name for 80 is a sub 1, what's another name for 77? A sub 2. What's another name for 74, Emma? A sub 3, very good. What's another name for 71, Caden? Why don't you look up top here? It's another name for 71. So we're calling 80 a sub 1, 77 a sub 2, because it's the first term, second term, third term. So what can we call 71? A sub 4. And lastly, Elijah? A sub 5. So we created our table. Cool. We got our A sub n. And now what I want you to do is I want you to identify consecutive terms. So consecutive terms. So what you're going to do, I'm going to put a little 1 right here. What you're going to do in step 2 is I'm going to find 2 consecutive terms. So a sub n and a sub n minus 1. What do we want? What consecutive terms do we want to use? Okay, you want to use a sub 3 and a sub 3 minus 1, which will be a sub 2. What you're going to be doing is finding the difference. So find the difference. Find the difference. So you are going to be subtracting these guys. So what was a sub 3?
74.
What is a sub 2?
77.
And what is 74 minus 77?
Negative 3.
-3. Now you're going to create an equation and that is going to be using a sub n and a sub n minus 1. So if I look at this and I rewrite this, I have a sub 3 minus a sub 2 is equal to -3. What did we say a sub 3 was here? Yeah. We also substitute a sub 3 for a sub n. I also substituted my a sub n minus 1 with a sub 2. And to create an equation where you have a sub n is equal to something, this is the confusing part. You're going to add your a sub n minus 1 to both sides. So a sub n is equal to a sub n minus 1, all minus 3. That is your answer. That is your recursive formula. So on your own paper, I want you to write a recursive formula or a recursive definition of these numbers. Now we're going to use 10, 20, 30, 40, and 50. So your instructions are up there to create a table, find consecutive terms, find the difference of consecutive terms, and then create an equation. And try and keep it within there. And you're gonna laugh that if you put your palm on that, that makes it a lot easier. So you're gonna be doing that. Yep. Oh, Lord. You got it, Professor. Oh, gosh. If you need to erase other stuff, that's okay. So you make your table with your n and your a sub n. Can you make that n a little bit smaller so it looks more like an a sub n? Microphone. Yeah, so let's, so you're gonna hit the back button, that's all the way to the left. Very good. So that a sub n, let's make that n a little bit smaller. There's an eraser along the bottom. So there's a little pin and a little eraser. There you go. And then you're gonna have to click back on the pin. Very good. There you go. So let's write out our terms. Look at you. You fit it in there. So our a sub 1 is going to be 10. A sub 2 is 20. A sub 3 is 30. A sub 4 is 40. A sub 5 is 50. And you can just identify the initial condition. So your a sub 1. Very good. All right. Josh, why don't you pop up and do our second step where you find the consecutive terms. We're going to be banking on your handwriting for this. If you can, go ahead and erase this stuff in the bottom right-hand corner. So which consecutive terms did you pick, Josh?
A sub 1.
Okay. So we had a sub 4. Mm-hmm. So you do a sub 4 minus a sub 4 minus 1. Look at you. So a sub 4 minus a sub 3. And we identified our a sub 4 as 40 and our a sub 3 as 30, which is equal to 10. So why don't you go ahead and do step 3 in green for me? Look at you dividing it off and everything. So you're going to have a sub 4 minus a sub 3 is equal to 10. You got it? But we called a sub 4 a sub n, and we called a sub 3 a sub n minus 1 being equal to 10. Don't forget your little 1 there. So the 0, it says 0 on the right-hand side. So make sure that's 10. Very good. So we're adding the a sub n minus 1. Very good. And so our formula is a sub n is equal to a sub n minus 1 plus 10. That is our formula. Very good. Now, I want to point out something that Ethan thought of that's actually the next step. You notice this on your own. But we can actually write what's called an explicit formula for this as well. Let me make sure I don't have an important example before I move on to that one. Okay. Before I show you what Ethan discovered, let's do one more recursive formula example, and then we're going to come back to that similar example. So let's do an example, and it'll say, identify if the following is recursive, and it'll say or explicit. We don't know what explicit is yet, so we should be pretty confident in what it is. And then it'll tell us to find the first 5 terms. So we are going to be given some a sub n equals a sub n minus 1 plus n plus 2. It'll say where a sub 1 is equal to, let's say 7. There's 2 different things here that we can identify that tells us that it's recursive. What 2 things are they? I put it in your definition. Do what? Yeah, so we have an initial condition. What else? Someone else. What do you think, Ethan? Yeah, consecutive terms. So it has this a sub n minus 1. That's how we know that it is recursive. So if we're finding the first 5 terms in the sequence, we are going to put our little table up. We're finding the first 5 terms. So 1, 2, 3, 4, and 5. And we already have our a sub 1 being 7. So if we look at it, a sub n is equal to a sub n minus 1 plus n plus 2. That's a mouthful. If we're looking for a sub 2, then that's a sub 2 minus 1 plus what? Our n was 2 plus another 2. So that's going to be a sub 1 plus 4. Our a sub 1 was 7. And so the next term is going to be 11. So I'm going to put 11 here. If I'm doing a sub 3, tell me what I'm going to put on the other side of that equal sign, Josh. Mm-hmm. Plus 3 plus 2. Very good. And this guy changed because that's our n. So that's going to be whatever the subscript on our a is. So this is going to be a sub 2 plus 5. We just said our a sub 2 was 11. So it's going to be what? 16? I want you all to find 4 and 5 on your own. All right, so Emma, why don't you help me walk through a sub 4? I know I'm going to write a sub 4 is equal to stuff. So what do I need to put on the other side of this equal sign? I left this example up here. Yeah, a sub 4 minus 1. Okay. Plus 4. Ta-da! Very good. So what am I going to put in the second line, Emma? Very good. What did we find a sub 3 to be? So we have 16 plus 6. So what is my a sub 4? All right, Kaden, walk me through the next one. I'm trying to find a sub 5. So what do I need to write after this equal to sign? A sub 5 minus 1. Okay. Plus 5 plus 2. What about the next line? A little louder.
A4.
So it's not quite A4. How do you read that correctly? Yeah. You got to say A sub 4, so we know what we're talking about. A sub 4 plus what? Five plus 2. 7. What did we find our A sub 4 to be? Kaden? 22. So we have 22 plus 7, which makes our A sub 5 equal to what? 29. Ta-da. All right. So now we are going to be talking about explicit formulas. An explicit formula is tons easier than a recursive formula, so you should be relieved. And the biggest way that we know that it's going to be an explicit formula is that it will have a variable in. Notice how the recursive formula can also have a variable in, but the recursive formula has other things like the initial condition and the consecutive terms. So let's talk about some variable in. Let's say we're told to, instead of saying find, I'm going to say identify if the following is recursive or explicit. Then find the first 5 terms. So identify if it's recursive or explicit, then find the first 5 terms. What you are given is A sub n is equal to 3n plus 2. Is this recursive or explicit? I'm spoon feeding you. Explicit. So someone else tell me why it's explicit. Yeah, because it has n as a variable. So if we're finding the first 5 terms, we're finding first term, second term, third term, fourth term, fifth term. Well, I wasn't given an initial condition, so what the heck am I supposed to do? You find it. You go A sub 1 is equal to 3 times 1 plus 2. So it'll be equal to 5. A sub 2 is going to be what, Elijah? What do I need to put after these equal sign? Times 2? Plus 2. So we have 6 plus 2, so that'll be 8. What about A sub 3, Haley?
You do 3, and then 3 in the parentheses,
So 3 times 3.
plus 2 equals 11.
And Ethan, a sub 4.
3 times 4 plus 2,
It's going to be what?
14.
And a sub 5, Caden.
A sub 5 equals 3 times 12 plus 2.
Very good. A sub 5 is equal to 3 times 5 plus 2. I like how you read that off. And that's going to be 17. Now that's not too bad, but let's sit back and think we could write a recursive formula on this, right? So each time we're adding 3, we could totally do that. So for this example, on your paper, trying to see if we have enough time. It'd be a good example for us to do recursive, but we will not. Let's do another explicit example. So let's say that we're given the following sequence, and we need to write an explicit formula for that. So let's say we have a sub n is equal to, I'm sorry, give us a little thing. Let's say that we've got 2, 4, 8, and 16. So we're going to identify if it is recursive or explicit. We're going to create a table. Let me put this in the orange like I did. Create our table. And see where we can move from there. So creating our table isn't so hard. We've got n and a sub n, and I just list my a sub n. Now, Ethan, do you have any guesses on if this is recursive or explicit? You think it's recursive? I'll tell you it is recursive. Why do you think it's recursive? Do what? Well, but so do explicit, right? Because this last time we had an a sub 1. Why did you think it was recursive, Josh? I saw that on your paper. There's no n variable. Yeah, well, there's no a sub n listed here either. What I want you to remember is this. Whenever you're looking at this table, if your n impacts your a sub n, so if it matters that it's the first term, then that is going to be explicit. If the change is from consecutive terms, one term to another, then that is going to be recursive. It is recursive because each of the values depends on the last value. So let's look at our pattern here. Whenever we're going from the first term to the second term, what are we doing? Multiplying by 2. When we're going from the second term to the third term, what are we doing? Multiplying by 2. And the third term to the fourth term? Multiply by 2. So if we think about it and we say this out loud, I'm going to say let's go with these two. The second term is what? The first term times 2? So the second term is the first term times 2. So we could write that as a sub 2 is equal to 2 times a sub 1. We know how to create a formula based off of this, right? Josh is nodding yes. What is going to be my formula? Do what? Well, so let's do, I'm sorry, I'm not being specific. Whenever we created our formula, that was whenever we had our variables. So our a sub 2, let's call this guy a sub n. We have 2 times, let's call our a sub 1 our a sub n minus 1. That is creating a formula. Yeah, so it's changing at how much we're increasing it by. So the second term is the first term plus 2. The third term is the second term plus 3. So let's see if we can write that out. Let's say that the third term is the second term plus 3. If we were to go ahead and create an equation out of this, what would we start with on the left-hand side? A sub n? Yeah. And then what would a sub 2 be? A sub n minus 1. Now let's notice something. This guy is being replaced for n. So this guy is getting replaced for N.